Now that we've done quite a bit with piecewise functions, let's go ahead and graph them from scratch. So here we have a piecewise function in function notation, and this one's going to be pretty simple because we have both of our lines starting at where x is 0, and x is 0 right on the y-axis, which means we can just use our y-intercepts. So for this one we have a y-intercept of 3, but remember that since this branch of the piecewise function is going to be less than but not equal to 0, we have to draw an open circle at where y is 3 to show that the branch does not include this point. And now we just follow our slope of 3 over 2 going in the direction where x is less than 0, which would be in this direction over here. So we're going to go up 3, left 2, up 3, left 2, and just draw the line. And now for the second part, we started a y-intercept of -5, but since we are greater than or equal to 0, we can fill in the point to show that it is included. And now we just use our slope of 2 going in the greater than direction, which is this way. So up 2, right 1, and we're just going to continue with that slope all the way up. Okay, that one's done. Now here we have a piecewise function with 3 separate parts. So what I'd recommend for this one is since your x ranges do not start at 0, they do not start on the y-axis, they start at -3 and 6. Actually they start at, this should be positive 6. Okay, yes, they start at -3 and 6. So let's draw some thin lines at where x is -3 and where x is 6 to help us graph these lines. So here is where x is -3, and here's where x is 6. So these are just guidelines. These are not part of the graph, but they're going to make graphing the actual function easier. So let's look at this first one here. F of x is -2x minus 8 when x is less than or equal to -3. So that means that we're only graphing the function itself is only in this area. But in order to find out where to start over there, we have to start at our y-intercept of -8. And let's draw -8. We're going to draw an open circle to show that that point is not part of the graph. That is not included. We're just using that for reference as well. And now we have a slope of -2, so we're going to go up 2, left 1, up 2, left 1, up 2, left 1. And now this is the point where we're starting on the line x equals -3. And since it's less than or equal to the function, or equal to means we can fill it in as a closed point. And now we just continue up with that slope of -2 and draw the line. Okay, now this part, f of x is x plus 1. The range for this is in between where x is -3 and 6. So in between these two guidelines that we drew. So if we started our slope of 1, now we can draw a closed dot because this is in the included area for the line. And we have slope of 1. Slope of 1 is just up 1, right 1, so we can just draw it like that. And since this part of the function includes 6, we can put a closed dot on the line where x equals 6 over here. Now going in the other direction to get to where x is -3, since that's the other end of this range of the x values, We'll continue with a slope of 1 going down that way. Now you'll notice here, this line should only be x is greater than negative 3, not equal to. But we hit where there was already a closed point filled from the other line. So since we can't really show a closed point and an open point at the same time, we're just going to leave it as a closed point. Because if you look at it, looking at the picture, on this line there is only one closed point, which means that this is still a function, because it's a function as long as it only has one closed point on every x value. So if we can't show the open circle, that's okay. And now the third one right here, we have a y-intercept of negative 4. But again, we're going to use an open circle because the included area for this function is only way over here where x is greater than 6. Now we have a slope of 1/3. So up 1, right 3. Up 1, right 3. And this is greater than but not equal to 6, so we're going to leave that as an open circle. And we continue with our slope and then draw the line like that. Okay, and now we have a piecewise function with 4 pieces. Again, they can have as many as you want. So here we see a problem. We see that the y-intercept is negative 17, so there's no way we can graph that on here. So what we have to do is first let's draw in our guidelines and see if that helps. So we're going to have, the guidelines are just where the ranges start for the lines. So we're going to have one at x equals 6. Another one at x equals negative 1. And another one at x equals negative 4. So now, this line is only included where x is greater than or equal to 6. So there's a lot we already know here. We know that we have a slope of 3 in this line. We have a y-intercept of negative 17. And since it's only included where x is greater than 6, it starts right at x equals 6. Starts where x equals 6. So the only thing we don't know, we know it's going to start on this line where x equals 6. We don't know the y value. We don't know where on this line it's going to start. So that's what we have to find. So let's use y equals mx plus b to find the y value. So y equals slope of 3 times x value of 6 plus y-intercept of negative 17. This will be y equals 18 minus 1, so y equals 1. And our starting point will be x of 6, y of 1. That's going to be right here. Yes, right there. So looking at that, we didn't even have to start on the y-intercept because we couldn't. So instead we used y equals mx plus b to calculate the starting point for this line. And now we can just continue with our slope of 3, up 3 over 1, and it's going in this direction. Okay, now the second one. F of x equals negative x between where x is negative 1 and 6. So for this, let's go back to our regular way of doing it, of starting at the y-intercept, which for this one will be 0. And we can use the closed dot because it is included in this section here. So going over to where the maximum of this range of 6, negative x is going that way. So we go right 1, down 1, like that. And because it does not include where x is 6, we're going to draw an open circle right there. But for where x is negative 1, it does include that. So we draw a closed point there. This one here, 1/4 x plus 8, we have a y-intercept of 8. Actually, let's use an open circle there, because the included area for this is between where x is negative 4 and where x is negative 1. And now we have a 1/4 slope, so we're going to be going a little backwards here. Instead of going that way, we're going to go this way. So we can go down 1, left 4. That's going to put us right here. And we're going to leave that as an open circle because this line does not include where x is negative 4. And this goes over to where x is negative 1. It does not include that point either. So that's going to be right around there. Kind of hard to draw that exactly. That will be our segment right there. And finally, this one we have y-intercept of negative 1. This time where x is less than negative 4, so all the way over here. So we got to get over there. We have a slope of 2 over 3. So instead of going up 2, right 3, we're going to go down 3, left 2. I'm sorry. No, instead of going up 2, right 3, we're going to go down 2, left 3. Right there. Let's do that again. Down 2, left 3. So now we're in the area we want, so we can close this point here. And so that is the line right there, but we're stopping at this point where x is negative 4. So it's only going to go up to right about there. But it does include where x is negative 4, so we're going to draw a closed dot right there. It's kind of hard to draw exactly, but that's about what it would look like. So those were some pretty challenging piecewise functions there. You had 4 different ones. You had to calculate the starting point because you couldn't plot the y-intercept. Then over here we had a weird thing where the closed point and the open point were hitting at the same spot. So if you understand these, then you have a very solid understanding of piecewise functions. And this is going to conclude our look at piecewise functions. Next time we're going to start with absolute value functions.